Okay.
Hello, welcome to
Hello.
this lecture on 3D geometry. I'm Chandra Vedanathan.
Okay.
I have my master's from University of Notre Dame, a PhD from University of Missouri, Columbia. Currently, I'm with the Global Institute of Innovation and Entrepreneurship. You can visit www.globaliie.com for more information about the Global Institute of Innovation and Entrepreneurship. Today, we'll be looking at planes.
Okay.
Will be our topic of discussion. So we'll first review the equation of a plane, things that we've already covered. So first is the general equation. We have the general equation of a plane to be ax plus by plus cz plus d equal to 0. This represents a plane in the most general form. We have the equation of a plane passing through a point x1, y1, z1 given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 equal to 0, where the coefficients a, b, and c are the direction ratios of the normal to the plane. Right?
Okay.
Then we also have the intercept form of the plane. It is of the form x by x1 plus y by y1 plus z by z1 equals 1. Fine, that's another form of the equation of a plane. Then, if you know the length of the perpendicular from the origin to the plane to be p, then we can have lx plus my plus nz equal to p to be another equivalent formulation for the equation of a plane. If we have two planes that are parallel,
in that formula, what's L, M, and N? That
those are
would
the
just be like,
directional cosines of the plane, L, M, and N.
right. Okay. Oh, it's just another way of writing. Okay.
Okay.
Yeah.
Now, if I have two planes, A1x plus B1y plus C1z plus D1 equal to 0, and A2x plus B2y plus C2z plus D2 equal to 0, then we say that these two planes are going to be perpendicular if the dot product between them, between the coefficients A1, A2 plus B1, B2 plus C1, C2 is equal to 0.
Yeah.
And we'll say that these two planes are parallel if they maintain the same ratio between the coefficients A1, B1 and C1 and A2, B2 and C2. So in other words, if A1 by A2 is equal to B1 by B2 plus C1 by C2, if these are equal, then you're going to have that the planes are parallel. Right? And one more little thing, if I have two planes that are intersecting, right, you will have the line of intersection. And suppose you're given two planes that are intersecting, and you want to find the equation of a plane that contains the line of intersection of two planes. What will be the equation of this plane? Take the first plane plus lambda times the second plane, that should be equal to 0, right? Because if I take any point that is common to both P1 and P2 and plug it in here, I'll get 0, right? It contains
And P1 and P2 the direction vectors
of on the line of intersection. I'm going to get 0 because it will satisfy P1. It will also satisfy P2. So I can formulate the new equation as P1 plus lambda times P2 equal to 0.
Okay, so here, what are P1 and P2 exactly?
Excuse me?
What are P1 and P2 exactly? Are they like the normal vector ratios to those planes?
No, P1 is the equation of the first plane. P2 is the equation of the second plane. P1 will probably be A1x plus B1y plus C1z plus D1 equal to 0. And P2 will be A2x plus B2y plus C2 plus D2 equal to 0. So I can formulate the new plane to be the first plane, which is A1x plus B1y plus C1z minus D1 plus lambda times a2x plus b2y plus c2z minus d2 equal to, this whole thing is equal to 0. Right? Is it clear, or do you want me to annotate this?
Yeah, actually, in the formula earlier that you gave, it was
Right, I
ax
can,
plus by plus
yeah. So plane 1 is a1x plus b1y plus c1z plus c1z equal to d1. So I bring the d1 to this side, so minus d1. This will be my plane 1.
Okay. Yeah. Okay.
Plus, I'm going to have lambda times, again, a2x
Right. Yeah.
plus b2y plus c2z minus d2. And this whole thing equal to 0. Cool? All right. So I can erase this off. Then let's go for the next idea, which is probably the last thing we'll do here in terms of revision. So length of a perpendicular from a point to the plane. Suppose I have the point x1, y1, z1, and I want to know what is the distance of the perpendicular that I can drop from the point x1, y1, z1 to the plane ax plus by plus cz equals d, plus ax plus by plus cz plus d equals 0. All I'll have to do is ax1 plus by1 plus cz1 plus d over square root of a squared plus b squared plus c squared. Fine? So these are the things that we will use in today's lecture to start solving problems. Are you okay with everything so far?
Yeah.
Okay. All right. So now let's start with problem number 1. And hopefully this will be an easy one. Let's look at, came in JEE mains. Find the value of k such that x minus 4 by 1 equals y minus 2 by 1 equals z minus k by 2. And this straight line, the symmetrical form of a line, this lies in the plane 2x minus 4y plus z equals 7. So you're asked to find what is the value of k here. So the options given are 7, minus 7, no real value, and 4. Okay. So what will be your strategy to solve this problem?
Okay. I would think that the point that we're talking about is 4, 2, k.
Yeah.
And we could probably just plug it into the plane equation.
That's right. That point should lie on the plane, right?
Yeah,
so for example, take a point on the given line. It will be in terms of k, because k is the unknown. In your case, you took it to be 4, 2k, right? On that point, use the fact that it is also on the plane to solve for k.
Yeah.
It will be our strategy, right? So if I have to visualize the situation, what are we asking? So here is my plane, and here is my straight line within the plane. If I have to make sure that this line is within the plane, what should be my value of k? That's what we are asking, right? This, for different values of k, this line will be differently projecting, right? In this case, it is now inside the plane, fully inside the plane. I can project it here outside the plane as well, right?
Yeah.
Yeah. So I can have different projections happening. Like for example, I can have something like this coming out.
Okay.
For different values of k, probably I'll have something else like this going up in this direction. Maybe I may have something going up like that. So for different values of k, I'll have the line either being on the plane itself or just projecting itself outside of the plane. The question is asking for what value of k will it be on the plane. And that's exactly the strategy we discussed. Let's go ahead and look at the solution using the strategy. So what we'll do now is look at the solution. Since the line lies in the plane, the point 4, 2k must be in the plane as well, right? So once we have that, plug it into the plane. 2 times 4, 2x, minus 4y, y value is 2, plus k should be equal to 7. If we solve for k, we get k equals 7.
Yeah.
Any questions on that?
No, I think that one was fine.
Okay, cool. Now let's go for problem number 2, which is slightly more involved than the first problem. This is a problem from JEE Mains 2015. The equation of the plane containing the line 2x minus 5y plus z equals 3 and x plus y plus 4z equals 5 and parallel to the plane x plus 3y plus 6z equals 1 is one of the following, right? Which one of these? A, B, C, and D. Now, if you read through the question, we want the equation of the plane, and we are told it contains the line 2x minus 5y plus z equals 3 and x plus 4y plus 4z equals 5. So what do you make of this? That I have this equation here and this equation here, and somehow it has to relate to a line.
I guess if these two lines, if the plane has to contain these two lines, that means the normal to the plane should be a common perpendicular for both the lines.
Now, this is saying the equation of the plane containing the line, not the lines. It's saying there's one line. So if you look at 2x minus 5x plus z equals 3, that's a plane.
Yeah.
X plus y plus 4z equals 5, that's another plane.
Another plane.
So really they're defining this line as the intersection between this plane and this plane. Whatever is the intersection, that is going to be a line.
Oh, okay,
and they want us to find the plane that contains this line, and this plane, not only does it contain this line, but it will also be parallel to the plane x plus 3y plus 6z equals 1. Okay. So now let's look at the strategy for this. What will be the strategy?
I was thinking of trying to find the line, like what the equation of the line will be, and I mean at least which direction the line is in, the line of intersection of the two planes, and then kind of equating the normal to the plane which is given in that the parallel plane. The normal of that should be equal to the perpendicular to that intersection line. So they should have a common normal.
Okay.
Going like that.
So let me give the strategy that I have, right? I'm going to find a point that is on both the planes.
Yeah.
Okay. Which is basically I'm going to find a point on the line of intersection of the two planes. Okay. And then what I do is, once I know the point, I'll use the fact that a required plane passes through this point. And it is also parallel to another plane. And we are given what is the other plane to which this plane is parallel to, and these two facts should be enough for me to find its equation.
Okay.
Sound like a strategy?
Yeah.
Okay. So let's see. Here is the visualization. I have this plane here. I have another plane here. And this is the line of intersection between these two planes.
Okay.
Right? And this is the line which should be contained in a now third plane should contain this line. And it should also be parallel to another plane which is given. Right? I don't want to complicate this figure too much, but this line should be contained in a plane which is parallel to another given plane.
Okay.
So we discussed the strategy. Shall we run through the solution to see how we execute the strategy?
Okay.
Here is the strategy. Here is the solution. So first, I'm going to let z equal to 0. Right? On the first plane, which was 2x minus 5y plus z equals 3, I put z equal to 0.
So z goes away, yeah.
So 2x minus 5y equals 3. In the second plane also, I make z equal to 0, so there is no z component to it. So I have x plus y equals 5. I have two equations, two unknowns. I can solve for them. I get y equals 5 minus x. And now, if I solve for them, I'll get y equals 1 and x equals 4. And now what I do, I know that this plane is also parallel to x plus 3y plus 6z equals 1. So what should be true then? If I'm going to assume my new plane to be a1x plus b1y plus c1z equals d1, then because the plane is parallel to x plus 3y plus 6z, a1 by 1 should be equal to b1 by 3, and that should be equal to c1 by 6, and all of this are equal to some constant k. Are you okay with that? That's because these two planes are going to be parallel to each other, and I'm going to assume that my plane is given by a1x plus b1y plus c1z equals d1. Fine? Then what happens to a1? a1 is equal to k. b1 equals 3 times k. And then c1 equals 6 times k. Just by equating a1 by 1 equals k, I get a1 equals k. b1 by 3 equals k, I get b1 equals 3k. c1 by 6 equals k, so c1 equals 6k. So which implies now k, which is a1, times 4 plus 3k, which is b1, times 1 plus d1 is equal to 0. Right?
Okay. Actually, where are these 4 and 1?
Here, we got y equals 1, x equals 4, z equals 0. This is a point in the plane. Right? So a1 times x plus b1 times y plus c1 times z, and z is 0, plus d1 is equal to 0. So we get d1.
Here a1, b1 and c1 are and d1 are part of the parallel plane that we have to find, right?
Yes.
Okay.
Right? You're okay with it now? Should I? Yeah. Do you have any questions? Should I annotate a little bit more, or you're okay with it?
No, I got this. Yeah, I got this one.
Yeah. Okay. So then, what do I get if I put all of this, and I have that k is not equal to 0, so I can pull k out. I know that a1 is k, B1 is 3k, C1 is 6k, D1 is minus 7k. If I plug it back into A1x plus B1, here is A1x plus, just a minute, B1y plus C1z plus D1 equal to 0. I'm now going to put for A1, I'm going to put hello. So for A1, I'm going to put k. For x, I mean for B1, I'm going to put 3k. For C1, I'm going to put 6k. And for D1, I'm going to put minus 7k. And k is not equal to 0. So I can pull k out of all of this. So it will become k times A1, so I have A1 is k, so it is x plus 3y plus 6z minus 7. This whole thing should be equal to 0. But k is not 0. That means x plus 3y plus 6z minus 7 is equal to 0. So I get the equation there. Fine?
Right. This is the equation of that plane that we're looking for. Right. Oh, wait.
Okay. So that is one solution. Shall I look at another way to solve this?
Yeah, actually.
All right.
Yeah.
So one of the things we discussed was if you have two planes which are intersecting and the line of intersection is contained in a new plane, what will be the equation of the new plane?
Wait, repeat that.
If I have two planes, P1 and P2, which are intersecting, and the line of intersection is contained in a new plane, what will be the equation of the new plane?
I think that the equation could kind of change depending on other parameters, right?
We reviewed it, right? It was P1 plus lambda times P2 equal to 0. Remember? When we did the review, we said that if P1 is a plane, right, P2 is another plane, and they're both intersecting, and the line of intersection is contained in the new plane, then the equation of the plane will be P1 plus lambda times P2.
Okay. Oh, yeah, I forgot that one.
Yeah. So now I have the first plane. I know what it is. 2x minus 5y plus z minus 3 plus lambda times x plus y plus 4z minus 5, and this thing is equal to 0.
Yeah.
Right? But now here I have to find what lambda is. Right here, lambda is unknown. If I can find lambda, I'm done. Right?
Yeah.
Once lambda is found, the equation of the plane is found.
Yeah.
So what I'll do is, I also know that this plane is parallel to x plus 3y plus 6z equals 1.
Yeah, okay. So we can use that, the ratio thing.
Yes, exactly. So we should get 2 plus lambda times x. You know, here is 2x, here is lambda x. So 2 lambda times x divided by 1, which is the coefficient of x here, should be equal to lambda y minus 5y. So I have lambda minus 5, lambda minus 5 divided by, what is the coefficient of y here? 3
3.
divided by 3, and that should be equal to, can you tell me what is the coefficient of z here?
That would be 4 lambda plus 1.
Yeah, divided by the coefficient of z here is 6. These should be equal, right? So if these have to be equal, Akshay, then I take 3 to this side, and
2.
then I multiply this. 3 times 2 is 6, plus 3 lambda should be equal to lambda minus 5.
Okay.
That means lambda, 3 lambda minus lambda is 2 lambda, should be equal to minus 11, which means lambda is equal to minus 11 by 2.
Okay.
And once I have minus 11 by 2 for lambda, all I have to do is go back and plug in lambda equal to minus 11 by 2 here, and that will give me the equation of the plane. And if I did that, I get x plus 3y plus 6z equals 3. Yeah. So there were 2 ways to solve this problem, right?
Yeah.
The first one, what did we do in for the first line of attack on the problem? Do you remember what we did?
Yeah, in the first one, we took a point. We found a point on the line of intersection,
Right.
And then we equated that point with the parallel plane.
Yes.
Yeah.
So we took a point, and to take a point, what we did was we made one of the parameters 0. We took z equal to 0, right? And then once we made z equal to 0, we got an equation in x and y, which we solved for x and y, and that gave us x and y, and we got x equal to 1 and y equals 4, if I'm not wrong.
Yeah.
And then we used that x, y, and z, which we found also lied on the plane, right? And we used that to find the equation of the new plane, right? So let's look at that.
Yeah.
So here is the first one. So let's look at the solution to that. So that was problem 2, and we wanted the solution here for problem 2. Solution 1.
Yeah. Okay. Yeah. This is the problem.
Yeah.
And
we will look at the solution. So that was the first strategy, and the second strategy was we knew the equation of the plane that contains the line of intersection of 2 planes. That was P1 plus lambda P2, and then using the fact that that plane is parallel to another plane, we found what the value of lambda was, and then once we found lambda, we could get the equation of the new plane.
Yeah.
Okay. So
I think that formula really makes it much faster.
Huh?
The P. I think that formula, the P1 plus lambda P2 equals 0, it makes it much faster.
Okay. So you like the second solution better than the first one because it's quicker.
It's much quicker, yeah.
Yeah. You didn't have to solve for x and y, so it kind of made life a little easier. Yeah. All right.
Yeah.
Okay. So that kind of completes the review of problem number 2, we'll go for problem number 3. So it's the visualization, just wait for a moment. So we have two planes intersecting, and then we'll go for problem number 3. So that's solution 1. And let's go for problem 3. I will